that data sample I mentioned, and therefore you can have your data sampling occur faster at these higher frequency separation spacings. So that's one of the key things that's being leveraged to get to a lower, what they call lower latency, and a faster communication. So basically going to a 30 kilohertz or 60 kilohertz gives you a 2x, 4x improvement in just your data throughput. Now there are the trade-off of that is if you went with a slower and a narrower subcarrier spacing is what this is referred to as, you can still keep the data. You're not losing or gaining data because you've effectively moved the data throughput more to a faster time, fewer subcarriers, versus a more subcarriers but a slower time. So the total rate remains the same. It's more of the data you're able to get stuff to you, go through the system faster is one way to look at it. So it's not that you're getting more data through, it's just some data, you're taking half the data and getting it through twice as fast, if that makes sense.
And so in the millimeter waves then, like in those 2, 3, and 4, they're able to move the data through at a faster rate.
Much faster.
Okay.
Right. And so when you have a lot of bandwidth to play with, as you do in the millimeter waves, this can be leveraged extensively to get your data through much quicker than what you would have in the more constrained bandwidths. So that's really one reason for millimeter wave, and the second reason for going to these higher levels of numerology.
And so you were saying that, like, for the 0 and 1 on that chart, 0 was what was traditionally used in LTE. It was all 15 kilohertz.
Right.
Okay.
So coming back, I guess another thing to keep in mind is we're talking about main communication, high-speed communication. In what we call the IoT, Internet of Things, you don't necessarily need a fast data rate. You need a very efficient from a battery consumption, because you might have something that's periodically on a very slow periodicity, sending data out from just a sensor that's monitoring, let's say, temperature, so you don't need it every tenth of a second, but maybe once a day, a couple times a week, something like that. Just to monitor parameters that may change slowly. So you can think of like a fuel depot monitoring the amount of fuel in a particular tank. It's probably not going to change quickly, so you don't necessarily need a fast data rate, but you need something that's going to be efficient, so you're not either needing to replace the unit, because it could be within a tank. The point is you can tailor the data requirement to optimizing other parameters such as the battery lifetime. So in those cases where data is not critical, we're actually going sort of the opposite direction, where instead of a 15 kilohertz spacing, we're going to a smaller spacing at a longer time.
Okay.
So a smaller frequency, a longer duration, because, again, not a lot of data needs to go through. And that can help on simplifying the overall system architecture. One thing that's related to faster data is you need to have basically the bandwidth as well as the system overall needs to operate at a faster rate to keep up with that data. Let's see. Coming back to this, so if you take the numerology, which is the mu factor over here, you can see we're going from 0 to 4. That has impact on sampling rate. So that means how often do we have to look at the individual data points coming through. So that increases. So this is what I was just talking about. You have to have a system that can sample at this rate So